All right, gang. We're going to go with our projectiles launched at an angle. Hopefully this is a little bit louder than it's been in the past. But projectiles at an angle, this is the most general case that you're going to see projectiles typically, is when they're going to be fired at some sort of angle. Some vocabulary words that you need to be aware of are things like range. And range is going to be your horizontal distance, and that's going to include your up and your down. Really, also, the other vocabulary word that you need to be aware of is hang time. And hang time is going to be your time up plus your time down. So once you find the time of one of these sides, it's typically going to be the same if it ends at the same spot. Remember when we talked about free-falling objects that went up and then came down? We made the comment that they could go the same amount of time up as they went down if they were coming to the same height, coming back to the same height, their starting heights. So that's important to remember. Also, the distance up is also equal to the distance down. So you'll typically only look at one or the other when you're dealing with these types of problems. We'll either look at the up trip or the down trip when we're dealing with the y information. And then for your x value, that's why we have to use the total time, because it's the x for the up trip and then it's the x of the down trip. So you have to remember that's how that happens. All right? Now, when we're doing problem solutions, upward direction is considered positive because it's like the positive line, really. So, really, when we think about it, acceleration is always downwards. So, when we use acceleration or g value, and we're saying that it's talking about the up part of the problem, then we're going to say that it's a negative 9.8 meters per second squared. If we're talking about gravity in its normal sense, which is down, then we'll say that it's the positive 9.8 meters per second squared. That's really all that's dealing with, because you just have to make sure that you use the correct sign for how we're talking about things. When you want to find when you're given an original velocity, you're always going to want to make sure you find its xy components. So that's going to be that your v of x value will, if it's drawn like this and you're given this angle, then this is your VO value, and this would be your VOX, and this would be your VOY. Remembering that this can be your VOY as it's going up, and then that can be switched if it's coming down. So remember that that's how that always works. All right? Now the horizontal and vertical components of its position at any instant can be found with these formulas. This is the same formula we've been using in the horizontal, and this is the same formula we've been using in the vertical. So remember that you can always find these values. Okay, plugging in gravity for acceleration and your VOYs in the correct direction. Okay, the horizontal and vertical components of the velocity at any instant. Remember, the horizontal stays the same, and we can use this part for this. Also, the final position and velocity can then be obtained from their components. So remember, we can end up coming up with a Vx value, and we can come up with a Vy value. And if we can do that, then we can end up doing things like or we have this, and then we have this, and we can come up with this resultant and its angle. So remember, you can always come up with those final positions and velocities by doing that. And you can also do your dx with your dy. So those values could always be put on that triangle. So that's something that we can come up with, and we can always come up with our dr and or our vr, then with its angle also. Just to let you know, as the angle changes, the range also changes. The most optimal angle is always going to be your 45-degree angle, so that's just something to be aware of. The higher the angle, the more vertical you're going to have, and the less x value you're going to have. All right. Same thing here. Again, you can look at the v value, and when you find the components, it's going to create different vy's and vx values, so it'll make that difference. All right. See you tomorrow in class.